So with this one is combining random variables, which means we're not just taking one variable and changing it, we're putting multiple variables together. It gives you rules there. Those are the rules, but I'm gonna start one and then we'll show why it is what it is. We're shorthanding here. If you're from the middle line this way, find Joe's mean and standard deviation. If you're middle line this way, find Sue's mean and standard deviation. So you A and B, you're either doing A or B right now. And let's just write down the answers instead of showing out the work, because for right now, I want to make sure I can get this covered. And it used X as the variable for Joe and Y as the variable for Sue. If you ever get to pick it, I would not pick X and Y. I would pick like J and S so that you don't keep having to remember which was which. But this one, I gave it to you. So what did we get as the mean for Joe's net profit? 2,000. And what are our units? What is the standard deviation for Joe's net profit? 3 what? Does it round to 50? Or does it stay at 49?
It rounds to 5.
Also dollars. So everybody needs to have that written down as A, whether you did that one or not. B, so this is for Sue. What is Sue's average net profit?
1,900.
And we're dollars again, 1,900. What is Sue's standard deviation net profit?
624.499.
All right, so Joe makes an average of $2,400, standard deviation of 663, 3250. Sue makes an average of $1,900 with a standard deviation of 624,499.4998. So let's say they live together, they want to put their money together, they want to see how much money they have on average, they want to know how much their money also is going to vary by. Mean, when we talked about anything with transforming, does mean ever work different than you think it would? You multiply, you multiply. You add, you divide, you divide. So mean rules keep applying that exact same way. You do exactly what you think is going to happen. So it gives us a letter here, doesn't it? Or does it not? Okay, so we need to define a letter. We'll just do T. Be the total net profit of Joe and Sue together. So how do I find mu of t?
That's just that.
Just mu of x plus mu of y. Combining mean, anything you do with means works exactly the way you would think it would. Put their money together. So how much did he make on average? How much did she make on average?
19.
So on average together they make now this is the one that gets changed depending on what happens. Standard deviation, it matters what you're doing to see what you do to it.
Use net profit mean.
Net profit is their combined profit.
Okay. And there wasn't anything to take away that we know of.
What?
And there wasn't anything to
Right,
take
right,
away.
right. So we need to know rules for standard deviation. The main rule is, or there's two rules. You can only combine in state of variance. And let's think about it this way. Let's say I make $5 an hour with an average or with a standard deviation of 2. $5 an hour with a standard deviation of 2. And I buy something that is an average of $2 with a standard deviation of 2. Right? So I have $5 with 2 standard deviation and 2 with 2 standard deviation. My end profit makes sense that it's about $3 on average, right? My $5 minus my $2. Now, would it make sense that my standard deviation was 2? My standard deviation was 2. If I subtract, I now don't have a standard deviation and all my answers are the same? No. You know what I'm saying there? Because if I subtracted 2 minus 2 equals 0, 0 means all the values are the same. So that doesn't make sense. So we never subtract standard deviation because of that, like because of that concept. So up here, the part that I didn't talk about, so it says if x and y are random variables, then mu of x either plus or y equals mu of x either plus or minus y, mu of y. Always follows those rules. So with the second one, I want you to write something out to the side. And our two rules are only combine. These are our standard deviation rules. Only combine in the state of, what did I say? Variance. Well, can I switch something between standard deviation and variance? Yeah, just square it or square it, depending on which way I want to go. And then what's my other rule? Always add. And so now you can see there it says sigma squared of x plus or minus y, but then it equals only plus because we're always going to add and we're always going to deal with combining and variances. So the part where we were at here, how much variability. So now if I want to find sigma of t, I have to do what? I've got both of my sigmas. What do I need to do with them? Square them. So I have a sigma of x, I want to square it. I have a sigma of y, I want to square it. What am I going to do with these two things? Add them. But right now, that's going to give me my what? Variance, but I want it standard deviation, so I just have to remember to what was my standard deviation of x? And you can actually rewrite that out and like type in what it is, but there's no reason to do it individually, just type it in the way it is. And then my other one was 624.94998. So I don't see any reason to do anything in between. I would just type exactly that in your calculator. So our variances were both, my lowest variances was 624. So what do I know my variance is going to be? Higher or lower than that? So I'm combining variance, or combining things. Is it going to go up or down? Up. And what is my new standard deviation? 9 what? Point. Do 4 decimals because we did no 4 decimals. Oh, 4 what? Is it around the 3, 4, or 6?
Yes.
And what are my units still? Questions of that problem? I'm going to go ahead and give you these. We've already done this one. This is a mu of x of 1.1. This is sigma of x of 0.9434. You plug numbers in your calculator, so I'm going to tell you what this one is. I feel sure that you can do that at this point. This one is a mean of 0.7 with a standard deviation of 0.6403.
Where is this coming from?
If I actually did.
Oh, you're
type
kidding.
that up, yeah.
That you're saying we already.
You already did the first one. The first one was from the problem on the other worksheet. I printed draws on the front and back, didn't I? I was trying to give y'all more room than I did. It already gave us defined as how we combine them. What do I write here? It already gave us that mu of t is x plus y, which is terrible explanation, but so how am I going to find mu of t? So t is like the total number of cars, something off the lot at that time. So how do I find mu of t? What was mu of x? What was mu of y? For a total of. And what of this one was number of cars sold. This one was number of cars leased. So we know that my units is what? I'm not worried about your interpret right now. Now, the one thing is we can't combine standard deviations unless the two variables are independent, which was said over there. They, in your 5 steps to a 5 book, they'll try to mix you up with that once or twice. You don't see it very often where they try to confuse you with that though. But it only works if they're independent, because if I'm giving like your math SAT score and your reading SAT score, there is dependency there, which means you don't independently add your standard deviations. Don't have to think about that one. Alright, so how do I figure out sigma of t? and sigma of x was 0.9434. Sigma of y was 0.6403. Square that, and then take the square root. Which gives us what? And what are my units? Now, in the last problem of this section, it might be on back. It is on back. Where it says define D as x minus y, do A and B really quick. It shouldn't take but a minute. Yeah, it's just saying it different. But I wish I would give more context. And I did copy the chart over, but I gave you the answers for the first sub, so. So what do I write for mu of D? What do I write for mu of D? And what was mu of X? What was mu of X? Minus, which gives me, what is this actually saying in context of the situation? That's the average number of what? On average, they sold more, 0.4 more cars than they leased. What would I write for sigma of D? So even though difference is minus, we never subtract, we always go through variance. So this ends up being the exact same thing that we just did.
Wait, why not?
We never subtract for standard deviation.
So you just add.
Now I need to explain what I'm going to have you do as your homework here. Because you're going to use part C. I'm just going to have you do part C from the adding section and not the subtracting. I want you to answer this in different pieces. Let's say find both of your new means. I want you to find both of your new standard deviations. And I want you to find does that make sense for what you're supposed to do? So there are ways where you can go straight here. I don't want to do it that way. So you're finding each of your new means and each of your standard deviations using the bonus. And once you have those, then put those together. And we're just doing it with the adding it. We're not doing it with the subtract one. So your homework, let's just say your homework's going to be that one. How many do I have left on the other page? 2 of them. There's one. Did I copy the one with the SAT? Yeah. Oh, SAT's on this one. So it'll be that problem, SAT, and skee ball. The one I wrote, SAT, and then on your other notes,